everybody. I'm very glad to be here with you and to present this session within the Sustainability Summit of 2025. I participated in the same event last year, and I was very glad to be a part of this event a second time. So I will just go to the second slide. So the title is the intelligence dilemma. Can AI and sustainability coexist? Problems with climate change, and also have a big tool, the AI, that can be at the same time, let's say, a tool that helps us have bigger performance in our projects, but can be also a danger, a threat for our planet Earth. So the table of context is so simple. So I will just talk about me, to present myself, an introduction. We will go through the presentation. We will finish with key takeaways and a Q&A session. So my name is Mehdi Elgurani. I am a project manager, an author of 2 books. So the first one is Rethinking Project Management for a Sustainable Future, and the second one was edited this year, so AI in the Service of Project Management, both edited by AFNOR in France. So I just translated the titles. It's in French, so for French speaking you can read them. For English speaking only, I'm so sorry. I'm searching for editors that can translate them. I'm also a trainer and a PMI contributor. So in this session, we will try to answer 3 questions. The first one is, what is the ecological cost of AI? The second one, can AI actually support sustainability goals? And the final one, the third one, what can we do as professionals to make both work together? So before exploring how AI can support sustainability, it's important to understand its current ecological impact. Artificial intelligence is not just, and we all know it's not just a digital tool. It consumes significant energy, produces substantial greenhouse gas emissions, and relies on massive and extensive physical infrastructure. So, in data centers and all the algorithms we are reading, producing to run it. And beyond energy, AI also affects essential and critical natural resources like water. So water is heavily used to cool servers, and its consumption, sadly, is expected to grow dramatically in the coming years. Finally, AI also generates large amounts of electronic wastes, which contains toxic chemicals, toxic materials that can harm and harms effectively ecosystems and human health also if not managed responsibly. So in the next 4 slides, we will look in detail at each of these challenges: water, energy, water, emissions, and electronic waste, to try to quantify AI's footprint and understand how we can manage this responsibly, and to understand the urgency of using this tool, AI, responsibly and sustainably. So let's go to the next slide. So for energy consumption, let's start with this aspect. So to have a sense of scale, let's start with a number. So according to the International Energy Agency, IEA, a single ChatGPT query consumes 10 times more than a regular Google search. So 10 times more it's already surprising. But the situation goes further. According to Sasha Lucioni, who is a specialist on the environmental impact of AI, she explains that generative AI, like ChatGPT or any other tool, consumes 30 times more electricity than any search or than any traditional or regular search engine. So when we use AI to generate text, images, or code, each one of our requests comes with a much higher energy cost than we imagine, really. So this shows that behind every interaction, there is a physical infrastructure existing. It's here. Thousands of servers running, cooled, and powered around the clock. So we know all that AI it feels magic, invisible, digital, but it depends on tangible energy resources. So it's a real problem. So let's look at the global picture. Data centers nowadays already represent around 1.4% of worldwide electricity consumption. And with the rapid growth of AI, this number could reach 3% by 2030. So it's the equivalent of the annual electricity consumption of France and Germany combined. So really understanding this is the first step, is a key step toward using AI more responsibly and more sustainably. We will go to the second aspect, which is emissions. So we know all that energy consumption always leads to greenhouse gas emissions. And since energy production is the most polluting sector on Earth, it's easy to see how the rise of AI has a direct impact on our planet's sustainability and on our planet's climate. So the numbers are really striking. According to a Reuters report, indirect emissions from major tech companies, we are talking about Meta, Amazon, Microsoft, and Alphabet, increased by around 150% between 2020 and 2023. And the big part of this surge is linked to the growing use of AI and the expansion of data centers around the world. So in total, AI-related activities now generate more than 102 tons of CO2 equivalent every year. We are talking about 102 million tons of CO2 equivalent every year. So to put this in perspective, that's roughly the quarter of the emissions by an industrialized country like France. So it's powerful. It's a powerful reminder that digital doesn't mean clean. Behind every algorithm, behind every query, there are machines and algorithms consuming energy and releasing CO2 equivalent emissions. So here's another way to visualize this problem differently. Training just a single AI model with 200 million parameters can produce the same carbon footprint as 5 cars over their entire lifetime, from manufacturing to end of life. Just one model. So the question is no longer whether AI has an impact, but it's how we can reduce this impact responsibly. And so far, we have talked about energy and emissions, but there's another problem. So the story doesn't end there. AI also affects the most important and the most essential elements for life on Earth, which is water. So even though it's a machine or it's about algorithms, it has what we call it's thirsty. So the cooling system in data centers require massive amounts of water to maintain the optimal temperature of servers that processes or that run AI models. So every query, every training session, every computation, every search that we do in AI tool, all of these generate heat that must be managed, and the solution is often water. So just to give you let's say a number for let's say that for training the the GPT-3, around 700,000 liters of fresh water was used to train this model. So let's say that the amount is really big. It's really problematic to use AI without having in mind that it can have, or it can be a danger for our planet Earth. So let's go to the electronic waste. So after everything we discussed in the previous section or on the previous slides, AI generated, or in 2023 alone in the world, we generated around 2,600 tons of electronic waste related to AI and digital technologies also only. So, and forecasts are even more alarming. By 2030, this figure could reach 2.5 million tons. 2.5 million tons of electronic waste. So that's roughly the equivalent of 13 billion of smartphones thrown away, just like this. Do you imagine the impact or the amount of what we generate as electronic waste? So it's an astonishing number that shows the scale of the challenge that we have ahead. But the problem is not just about quantity when we talk about electronic wastes, because electronic waste is not just like any other household waste. So it contains heavy metals, rare earth materials, and toxic chemicals that are extremely harmful to soils, to oceans, to biodiversity, and to human health. So when improperly recycled, these substances contaminate the environment and threaten the ecosystems and our human health. So all these aspects, energy, emissions, water, and waste, are closely interconnected. So to illustrate this, consider just the production of just one computer. It requires about 230 liters of fossil fuels, 20 liters of chemicals, and 1.5 tons of water. So even before an AI system starts running, its environmental impact has already begun. So after everything we discussed in the previous section, it's easy to feel that AI and sustainability cannot work together. Many people even think that the idea is unrealistic or improbable. So, but some real experiments show that it's the opposite. In several situations, AI has helped organizations to reduce their impact and improve their sustainability performance. So in the next part of this presentation, we will look at concrete examples using the classic sustainability model, the three P's of the triple bottom line: planet, bottom, and planet, people, and profits. So over the past years, since ChatGPT has made his coming in the let's say in our use in the project management, so many initiatives have shown that artificial intelligence can actively support the sustainability of our planet. And this environmental dimension is the most visible and the most widely discussed, and it's for a good reason, because AI delivered actually measurable and concrete results in real-world applications. So the first example concerns energy consumption. So according to a Time article, Cambi, which is a property management company, used an AI system called Brainbox AI to optimize its HVAC installations. So over 11 months, energy use for cooling and heating dropped by 15.8%, while also reduced carbon emissions by 37 tons. So this is a remarkable achievement and a strong example of AI-driven optimization in practice. The second example is about energy efficiency. So in France, EDF, which is my client, by the way, so electricity of France, it's the national electricity provider, applied AI-powered predictive models to improve demand forecasting. So by AI or by using AI, forecast accuracy increased by 25%. And this allows electricity production to match consumption more closely. And consequently, this reduced energy waste and shows how AI can help us manage more effectively complex infrastructure, because EDF are using nuclear energy, low carbon energy, renewable energy to manage their energy park. So it's really, really complex. So the third example focuses on water efficiency. In Argentina, a company called Quilimo uses AI to help farmers optimize irrigation. So according to an article on The Guardian, this helped them to reduce water consumption by 20%. And this provides meaningful progress for regions facing water scarcity, like my country, Morocco, for example. We have a big problem with water as a natural resources for our personal use, for industry, for the cities' facilities, and every use of water. So these three examples represent really just a fraction of the efforts ongoing. Demonstrate that when used and applied wisely, AI can become a genuine ally for environmental sustainability. So now let's talk about the second key of sustainability of the triple bottom line, which is people. In this context, AI can serve interests of project teams, clients for client satisfaction, and any other stakeholders, enhancing at the same time well-being, ethics, and satisfaction. So the first example I will give focuses on work-life balance. Microsoft developed an AI tool called My Analytics to help their employees better manage their health and their time, their working time. The results are really striking, because employees reduced the amount or the number of emails sent after working hours by 24%, while at the same time, productivity increased by 38% for the people who are taking regular breaks. So it's managed their working time, breaks time, and the like. So these improvements support both professional engagement and personal well-being. So that shows that AI can positively influence daily life and enhance or make the work culture better. So the second example addresses ethical supply chains. There is an electronics component manufacturer, which I don't remember the name, which implemented an AI-powered compliance platform to monitor its supplier network and reduce the forced labor incidents. So over 2 years, they succeeded to reduce the forced labor incidents by 40%. And this, another time, demonstrates how AI can help companies uphold human rights, ensure ethical practices, and make their operations more socially responsible. And the third example I will give highlights the customer satisfaction and the customer engagement. At Shanghai Airport in Singapore, AI is used to, at the same time, to screen luggage and to facilitate biometric checks. So by reducing queues at security and speeding the passenger flow, the airport improves efficiency and at the same time enhances the traveler experience. So such innovation, let's be clear, increase customer satisfaction and demonstrate that AI can contribute to sustainable service delivery in this human dimension. So for the second P. So these three cases, another time, illustrate just a fraction of AI's potential to support people within projects, so to make projects human-centered. And they show how responsible AI, let's call it a responsible AI, can improve health, ethics, and satisfaction. And this example inspires us to explore sustainable applications that benefits everyone involved in our projects. So let's move to the third P, which is the profit. So environmental responsibility and social well-being are essential. They are crucial, but companies also need financial health. It's normal to continue operating. So the true sustainability, the real sustainability, requires a balance, and this balance is somehow organization that protect planets, that help and support people, that can maintain a strong financial performance. So the first example I will give concerns financial reporting. So by automating the SFDR is Sustainable Financial Disclosure Regulation. So by automating the SFDR reporting, the company Clarity AI, they have a generative AI that help them reduce manual efforts by 80%. And this allow their asset managers to focus more on strategy, on client service, on client satisfaction, and on decision making. So this helped them generate more financial value while at the same time ensuring compliance and efficiency. The second example highlights internal audits improvement. Westrock, which is a global company working for producing paper and packaging, uses AI to enhance audit processes. So they use AI to generate risk summaries, to optimize internal financial reporting, and this helps the company to make faster and more informed decisions, and consequently to generate more financial value. And the third example that I kept at the final place, so it's directly or it concerns a direct financial improvement. So according to a Financial Times article, the Norwegian oil fund saved $100 million in $2 billion annual $2 billion in annual transaction costs, thanks to AI programs. So they used AI programs to save around 5% of their annual transaction costs. And this shows how AI can directly improve financial health while supporting sustainability goals. So these examples, for a third time, clarify the picture. So significant costs, that's clear, and we show that the but wisely, when used responsibly, it becomes a strategic lever that serves time, planet, people, and profit.
Hi, Mehdi. Sorry. The last minute or two, we couldn't hear you because the internet connection didn't work very well.
Okay. So I will repeat the last slide. Is it okay?
Thank you. Yeah.
Okay. So I I was talking about the third P of sustainability, which is the prosperity or profit. So, as I said, that's environmental responsibility and the social well-being are essential. They are crucial for any company, for any human being working or living just on Earth. So, but companies also to continue operating, they need some financial health. So the genuine or the true sustainability requires a balance, and this balance means that we have companies that protect planet, that support and help people, but at the same time, it's important that maintain strong financial performance. So this first example, the first example I will give concerns financial reporting. By automating SFDR, and I give the meaning of this, so it's sustainability financial disclosure reporting. The company Clarity AIs, they have a generative AI that help them reduce about 80% of manual effort for their employees, and this helped their asset managers to focus more on strategy, on client service, client satisfaction, and consequently this helped them generate more value, while at the same time ensuring some compliance and efficiency for the company. And the second example I talked about is for internal audits improving or improvement. So Westrock, which is a company that produce packaging and paper, uses AI to enhance their audit processes. So they use AI to generate risk summaries, to optimize financial reporting, and this help the company to generate more financial value and to have a more, let's say, a bigger or a better financial performance. And the third example is about direct financial improvement. So, according to the Financial Times, the Norwegian oil fund saved around $100 million and $2 billion of annual transaction costs. So, and this thanks to AI programs and AI algorithms. So, we are talking about 5% of their annual transaction costs. And this shows how can AI or how AI can directly improve financial health while supporting the sustainability of the company and of our planet Earth. So these examples shows for the third time that AI can be a lever that serves at the same time planet, people, and profit. So the challenge is to use this double-edged tool while maximizing benefits, but without further harming our vital environment. So let's go to the third question. So what can we do as professionals to make both sustainability and AI work together? So implementing AI in projects can target various returns on investments, or ROI, including financial, management, performance, productivity, and compliance or commercial gains. However, we saw that environmental costs and benefits must also be considered. So we have an environmental cost that we must consider in elaborating or in let's say building our ROI perspective. So to understand how AI can sustainably and AI and sustainability can work together, we could use what I call a sustainable ROI, and this will be the common reference between both AI and sustainability. So this approach balances AI as a tool to help us maximize profit benefits with sustainability as a project constraint. So achieving this requires clearly defining ROI parameters. So when we will define our ROI, we have to set some parameters. So they should be well defined, and this will ensure that these parameters are tracked and fully traceable to responsibly do decision making about the project and to deliver value, a sustainable value at the end of the project. So it's important to know that any ROI depends on the context. So it's important to understand that this sustainable ROI will vary depending the context of the organization and of the project. Even if we have some benchmarks of similar organizations, similar projects, local constraints will influence results significantly. So one factor is energy production. For example, an organization using AI in a country heavily reliant on fossil fuels, like a company, for example, operating in Morocco, we have around 90% of fossil fuels in our energy mix, will generate different environmental impact compared with a company operating in a country that use or that generate renewable or low carbon energy. So it's a fact. Another key factor is the political and technological environment. So policies, regulations, and the existing infrastructure can either support or hinder AI adoption. So these conditions directly affect initial investment and consequently the final ROI, the final sustainable ROI. And this highlights the importance of the analysis or the initiative phase of the project. When we are planning or we are initiating our project, we have to consider this. So carefully assessing the current situation, where we are, what's our condition, in which country we are operating. This will allow organization to set realistic objectives, to define achievable ROI targets, achievable sustainable ROI targets, and implement AI solution more responsibly by balancing both project performance, project value, and sustainability goals. So let's talk about some simple solution that we can apply to have this sustainable ROI. So here the principle prevention is better than cure is really crucial to achieve a sustainable ROI from AI in projects. So several best practices can be adapted to each project and to each team, to each country. So first, we can set a carbon or energy, let's say, a budget or threshold for AI usage. So we can use AI, but we have some limits of usage. So we can define a maximum limit, maximum threshold for energy consumption or greenhouse gas emissions linked to AI to align with broader company low carbon goals or broader country low carbon objectives. So if this monitoring is, and it is actually, if this monitoring of energy and emissions is difficult, we can't do it. So we can set a quota or a limit of prompts, and this can help. We can limit the prompts used in the project. So we can limit the number of AI requests per project or per, let's say, work package, for example, or per program. So, and we can reset this quota based on the team responsibility, the team engagement, or the progress of the project. Next, we can implement some access control by role or by maturity level. So we will just, for example, allow AI the use of AI to train the members of the project or the members who have some significant potential for using AI and to deliver the real value of it. And finally, we can integrate digital sobriety indicators into project dashboards directly in our dashboards. So these indicators will track AI sustainability, and they will make AI both a tool for project and a measurable objective. So we have limits, we have objectives that we will reach. And adopting these practices provides some strong monitoring KPIs, monitoring indicators, and ensures projects implement AI responsibly, sustainably, and this will align with the organizational sustainability goals or even the country sustainability goals, while maximizing product performance. So we will use this tool AI responsibly, and more sustainably. So how we can measure the good use of AI? So we know that AI is a powerful tool to enhance project performance and project management performance and track the overall performance of our projects, and then to ensure the sustainable AI use, several KPI can be monitored, ideally combined with the existing organizational systems. So first, we can track energy consumption per project or per work package, as I said. Next, we can measure the greenhouse gas emissions equivalents linked to AI usage. Then we can monitor the share of renewable energy powering AI. So this will give us how much renewable energy we use to power AI, and this could reflect the overall sustainability of the project. Finally, we can monitor the circularity of AI hardware, because we have the electronic waste as a problem. So we can monitor, we can check, we can follow the circularity of AI hardware used in our project. So how much is reduced, how much is recycled, and how much is reused or reduced. So this will help also to measure the overall sustainability of the approach that we are taking in our project. So, but we can add some KPIs that can be developed based on each project's capability or project constraints. So the goal is to make AI a responsible, maintainable, and measurable tool, proving its value while minimizing the environmental impact and supporting sustainable project practices and processes. So this is this is the final slide. So for some key takeaways, so what we are doing, so we are using AI to improve project performance. So it's a fact, no. Its environmental impacts, it grows, and we have shown this in the first section of the presentation. And this forces us to rethink how we measure value and sustainability. So what can be done? We can adopt sustainable ROI to monitor key indicators, and apply responsible practices to ensure AI that supports really performance while reducing negative impact. And what need to be taken care of? So we must balance benefits and costs, question impacts early, and track energy and emissions to and ensure AI to remain ethical, efficient, and environmentally responsible. Thank you. That's all for me, and I will see if there is some
Yes,
question.
thank you, Mehdi. I
Thank
will
you,
raise
Mariam.
maybe one quick one, if that's okay. Thank you very much.
Thank
We are
you.
going to go 1 or 2 minutes over time, but do you have experience with measurement tools for carbon or energy consumption and other indicators to make the effect of daily project work more transparent?
I confess it will be difficult to measure every day the AI footprint in a project. So we can use some AI tools to develop some other tools. I will say to measure this. Maybe it will be impossible, or it's already impossible. Personally, I don't have specific experience with this, but we can, for every project, measure the energy used by this project. It's possible, and maybe we can measure the fraction or the amount of energy used by AI. Maybe the energy used by the processors or the data centers that we are using, and have a rough order of magnitude of this energy spent or used for AI. So maybe that we can develop some tools to do this. But personally, as I said, I don't have specific experience with this.
Okay, lovely. Thank you very much. So we now can move over to another small networking session, and I encourage everyone to join that for a few minutes before the next sessions begin. If you stop sharing, Mehdi, I'll just see if I can share the next session information.
Yes.
I can successfully navigate that.